systems of inequalities. Before we look at a system, we want to look at just a simple inequality in two variables. We have never seen that before. Maybe you have in previous classes. So let's start with a simple situation. Let's say number 2 on page 599, 3x minus 6y less than or equal to 12. As I said, in this class we have never seen this before. What we have seen was, let's say 2x minus 1 greater than or equal to 2, so 2x greater than or equal to 3, x greater than or equal to 3 halves. But that's not the issue here. We have two variables. We can do this. So how do we solve such an inequality with two variables? This is not a system yet. This is just an inequality. We're talking about inequality first and then systems. Okay, so here are the steps that we need to follow when we solve a inequality with two variables. Linear or not. This is a linear, and then I'll show you a nonlinear before we look at systems. So first step is create the corresponding equation. You can say, are you changing the symbol? No. I just write this because I need it for step 2. I'm not changing that. In step 2, I have to graph 3x minus 6y equals 12. Well, I know how to graph this. It's a linear function. I need the x and y intercepts. When x is 0, y is negative 2, so 0, negative 2. When y is 0, x is 4, so 4, comma 0. Okay, so I'll graph this. And I have 0, negative 2. Any questions? Stop me, please. And 4, comma 0. I stop for a moment to check whether this inequality has the equal symbol. If it has the equal symbol, and it does, the graph of the line will be solid. Line or curve or function, whatever it is. So this is 3x minus 6y equals 12. This is just the line. In step 3, I pick a point. A point where? Well, I notice that this line divides the entire plane into two regions, the one below it and the one above it. So I see that the easiest point to work with is 0, 0, and that point is above the line. So I'm really using 0, 0. By using 0, 0, I'm checking this territory. Okay, here's my inequality right here. 0, 0. Is 0 less than or equal to 12? If you say yes, if you say it's true, then I will shade in the area where the point is coming from. If you say false, then I will have to shade in the opposite area where the point is not, on the other side of the line. Is this true or false?
True.
Therefore, we are going to shade in that particular region where the point is coming from. So therefore, this is all this territory, and this is the only way we can graph or present the solution. All this blue territory, including points on the line, it's the region that solves the entire system. Solves the inequality. In other words, if you pick a point here, whatever this point is, it will verify the inequality. If you pick a point here, yes. If you pick a point here, yes. A point here, yes. If you pick a point here, no. and this is the only method we have for solving inequalities with two variables. Here's another example before systems. Any questions for me? I caution you that if the line or the function or the curve passes through the origin, you cannot use the origin. So if I have this situation, let's say not this line but this line, I would pick a point here and say 0, 10. Or I would pick a point here, negative 10, 0. Or I will pick a point here, negative 10, negative 10. But I can no longer use the origin if the line passes or the curve passes to the origin. At any other time, I will always use the origin because it's the easiest to work with. Okay, 15 on the next page. It says x squared plus y squared greater than 25. I follow the same steps. I have to write the equation first. And now I have to graph it. What is it and how do I graph it? We had it on the previous test, and you all graphed it. 2. Anyone? I know you know what that is. I will give you 2 hints. That's all I can say, and now I'm on strike. I know, I'm kidding, of course.
Equation of a circle.
Excellent. What is the center? Awesome. Nothing is added, nothing is subtracted. What could be the center?
0.
Comma 0. Very good. And the radius?
5.
That's it. Oops. Now, I cannot draw before I make a decision. Solid or dashed?
Dashed.
Yes. Just this, just the circle, is x squared plus y squared equals 25. Now I can see that what happens here. I see 2 regions, the interior of the circle and the exterior of the circle. Of course, since it doesn't pass through the origin, my preference point is definitely 0, 0. So I get 0 greater than 25. If this is true, I shade in the inside. If this is false, I shade in the outside. What do I shade in?
The outside.
That's it. Not points on the circle though. So all this area is x squared plus y squared greater than 25. Notice that the circle is the equation. The territory is the inequality. Do not confuse the two. Do not write that this is the inequality because it's not, it's the equation. And all this region around the circle represents solutions to this. Now we have the prep for systems. So let's start. Let's start with a linear system first. Let's say, I just saw one that caught my eye. Okay, yes, 40. On page 600. 4x minus 5y greater than or equal to negative 20, and x greater than or equal to negative 3. Okay. Now I will have to repeat the same procedure that we just looked at, that we just used in the previous two examples for each. When I'm done with this, completely done with this shaded and everything, all the area, then I move on to the second one, and then I overlap them. If they don't overlap, the system has no solutions. So then, let's start with the first equation, which is 4x minus 5y equals negative 20. Not a big deal when x is 0, y is 4. So 0, comma 4. Now when y is 0, negative 5. So negative 5, comma 0. Zero, 4. 1, 2, 3, 4, 5, 0. I check, solid or not? Yes, it's solid. This is just the equation. I have to write 4x minus 5y equals negative 20. Luckily, it does not pass through the origin, so I'm going to use my favorite point, and I'm checking the bottom area. 0, 0. Is 0 greater than or equal to negative 20? If you say yes, I will shade in the area that has the origin. If you say false, I will shade in the opposite. Is 0 greater than or equal to negative 20?
True.
True. So I will have to shade in all this. This is 4x minus 5y greater than or equal to negative 20. So this is done. Only now I can move on to the next one. But the next one is the easiest thing. X equals negative 3, 1, 2, 3, is this line and it's solid. How come it's solid? Because of the equal symbol. And it says x, I don't need to pick a point, just x greater than or equal to negative 3. So which side of x equals 3, x equals negative 3 will I shade in? This side or this side? And again, here there is no need to pick a point. So I will shade in the right hand side. All points here in the red territory have whatever y, I don't care, but they have x greater than or equal to negative 3. I see two colors. I see blue and I see red, and I see where they overlap. All points on this line, all points on this line, and everything in between. This is the system. The solution to the system, all points that verify both inequalities are here. Here just one, here none of the above, and here the other. But I'm interested in the system. That's where I want both. So this is where I would pick solutions. All this area consists of the solutions of the system. Any questions? Let's look at 47 on same page. And this is it. This is the end of chapter 5. Okay, we have x squared plus y squared less than or equal to 16. and x plus y greater than 2. I'm hoping that by next week you're going to come up with some questions from my math lab, because I want to review with my math lab anyway. My lab math, I'm sorry. Okay, so I know how to proceed. I have x squared plus y squared equals 16. I know what that is. What does it represent? What is it? How do I graph it?
A circle.
Yes.
With a center of 0, 0,
Yes.
and a radius, or
Yes.
4.
Yes. Perfect. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And it's a solid curve. This is just x squared plus y squared equals 16. It divides the entire area into two regions, the inner and the outer. And when I plug in 0, 0, my favorite point, 0 plus 0 less than or equal to 16 is true. All this inside, including points on this circumference, represent solutions to this inequality. Now we proceed accordingly, same steps, everything the same, with x plus y equals 2. Let me write it here. So x plus y equals 2. When x is 0, y is 2. So 0, 2. Again, the other one, when y is 0, x is 2. So 2, 0. Nice. So 2, 0 and 0, 2. But this is not a solid line. So I will graph it and write on it x plus y equals 2. This is just the equation. And I see that it divides the plane into two pieces, the right and left. And my favorite point is right here, 0, 0. Is 0 greater than 2? If you say yes, I will shade in the territory that consists or contains the point that I picked. If you say no, it's false, then I have to shade in the opposite side. Is it true or false?
False.
False. So I cannot pick this territory where the origin is coming from, because it gave me a false statement. So what I can pick, though, is the opposite. All this territory represents x plus y greater than 2. But since this is a system, I want both conditions. That's why we've done that with systems all along. When we got a solution, we went back to check in the original problem, because we wanted both equations to be true at the same time. The same thing here. Now I want both inequalities to be true at the same time. So does this and this, do these two territories overlap? Do they overlap?
Yes.
Yes. All points on the piece of the circle, points very, very close to the line, and everything in between. This is the system. Or both, if you want, the same thing. So if we want to pick value, ordered pairs that verify the system, we have to pick them in the orange territory. And now you can say, okay, fine, this is so interesting, but where is this applicable? Well, it's applicable in the next section that they removed from the course. I know it's painful, but the next section is extremely interesting. It's called linear programming, but it has been removed for years from the course. Yep. Okay, we have time to look at one more. 56 caught my eye. Any questions on this? And it's
Can these come as a word problem as well?
not really, because the word problems are in the next section.
All right.
Yeah, I'm so sorry. But if you find something in my lab math, please bring it across so we can do it together. 55. So x squared plus y squared less than 16, and y greater than or equal to 2 to the x. Now I can put the book away. Okay, we know the first one by heart by now. It's x squared plus y squared equals 16. We just had that a minute ago. It's a circle centered at the origin and goes 4 units, 4 units, 4 units, 4 units, and it's not solid. By not solid, it means that we cannot take the points on the circumference as solutions. That's all it means. X squared plus y squared equals 16. My favorite, 0, 0, I get 0 less than 16. Yes, okay. So this inside represents x squared plus y squared less than 16. But now, this is why this caught my eye. I have y equals 2 to the x. And this is our previous chapter. What type of function is this?
Exponential.
Thank you.
Sorry, my dog started barking.
That's okay. So 2 to the x, because the base is greater than 1, it will be increasing, and it's a pure exponential. It will definitely cross at 0, 1. And it is a full solid curve. It doesn't pass through the origin. I will check the origin, meaning I will check this territory. 0, 0. Careful now. 0 here, 0 here. 0 greater than or equal to, how much is 2 raised to 0?
1.
Perfect. If you say it's true, I will shade in the area that has the origin. If you say it's false, I have to shade in the opposite. True or false?
False.
So I cannot shade in the area that contains the point that I used. I have to go to the other side. So this is y greater than or equal to 2 to the x. And now I have to find the common elements where both inequalities are true. Do these two territories, do they overlap?
Yes.
Yes, they do. So all points on this curve, but not points on this curve, but everything else. This is the system, or both inequalities at the same time.